Albert Einstein once said that no matter how advanced our telescopes become, we will never be able to see the beginning of the universe. However, a recent discovery by the James Webb Telescope might offer an extraordinary clue about the birth of the universe. What was observed was a massive void between galaxies, raising significant questions about the origin of the universe. This groundbreaking discovery could provide important answers about our existence and shed light on the conditions that prevailed during the early periods of the universe. Albert Einstein's prediction was likely correct. How can we observe an event that emits no light? This event not only occurred in darkness, but also challenged our understanding of the physical laws of our universe. Approximately 13.8 billion years ago, a singularity emerging from a small point deviated from its equilibrium due to a minor irregularity. This singularity transformed into the universe we know today. Interestingly, remnants of this original point can still be found in black holes. The gravitational forces within these black holes in our universe are so strong that they approach infinity. The James Webb Telescope, NASA's latest space observatory, potentially captured images of a black hole and a vast void at the dawn of time. The emergence of the first stars in the cosmos occurred shortly after the Big Bang. Imagine this early universe, a dense mix of particles and radiation expanding at a staggering rate. There was no light in the traditional sense because photons, the fundamental particles of light, were constantly interacting with free protons and electrons, preventing them from traveling freely through space. After the Big Bang, the cooling of the universe allowed the formation of the first neutral atoms, primarily hydrogen and helium. This cooling process took about 380,000 years, allowing photons to move freely and leading to the formation of the cosmic microwave background. However, the universe remained dark because there were no light sources like stars or galaxies yet. A few 100 million years after the Big Bang, the formation of the first stars and galaxies began. These young, hot stars emitted intense ultraviolet radiation that ionized the surrounding neutral hydrogen atoms. This ionization split hydrogen atoms into protons and free electrons, making the universe increasingly transparent to ultraviolet and visible light. The formation of the first stars and galaxies occurred under the influence of gravity. Clouds of hydrogen and helium condensed, reaching pressure and temperature levels sufficient to initiate nuclear fusion. This fusion took place in the cores of these first stars, producing light and illuminating the universe for the first time. As the universe became more transparent, the radiation emitted by these stars and galaxies ionized the dense, neutral hydrogen fog that had enveloped the universe until that point. This process continued until the entire intergalactic medium was ionized, marking the end of the Dark Ages. As we currently understand it, this was the birth of the universe. Our observations, even with the most advanced telescopes, are limited to the point where the universe became transparent and light could travel freely. Scientists had assumed that this milestone occurred about 380,000 years after the Big Bang. The James Webb Space Telescope is known as the most advanced and powerful telescope to date. Equipped with its 16 hexagonal mirrors and the latest infrared technology, this telescope is tasked with uncovering the secrets of the universe's origins. This extraordinary telescope captures light signals that reach us and has made significant advancements by discovering ancient galaxies spanning 13.5 billion years. Now, it has made the exciting discovery of a black hole that existed just 500 million years after the Big Bang. This finding challenges our understanding of the early periods and objects in the universe. Although this particular black hole is not the largest known, it is extremely ancient and has a mass approximately 10 million times that of our Sun. Black holes are vast, empty regions devoid of matter, but they possess extraordinary gravitational properties. You might wonder how something seemingly empty can have so much mass. Scientists explain this by suggesting that black holes gain mass as they consume matter, or that mysterious dark matter plays a role. Dark matter, like black holes, is invisible, but its existence is inferred through its gravitational effects on spacetime. Scientists made another astonishing observation about the black hole discovered by the James Webb Telescope. It is growing at an incredibly fast rate, and considering these growth rates, researchers are baffled by the cause. Based on our observations, they suggest that this black hole should be older than the universe itself, which seems like an impossible scenario. However, we cannot entirely dismiss this, as there are theories suggesting that certain elements of our cosmos could have existed in a precursor universe. At the same time, it is conceivable that black holes in the early universe could have had entirely different properties from those we observe today. Observations from the fascinating discoveries made by the James Webb Telescope have shaken established theories and exposed flaws in our current understanding of cosmology. Massive black holes growing at unprecedented speeds and galaxies that appear to predate the universe challenge the foundations of previously accepted theories and calculations about the Big Bang and its aftermath. Scientists now face a daunting challenge that could lead to a complete reassessment of our cosmological worldview. New theories are emerging, and old ones are being revisited. The theory of variable physical constants suggests that the laws governing the universe at its inception were significantly different. Fundamental, physical constants, like the gravitational constant or the fine structure constant, could have had entirely different values during the early stages of the universe. Such variations could explain the rapid growth of black holes. Another intriguing approach to the formation of galaxies and the mysterious expansion of black holes is the theory of quantum gravity, which aims to reconcile Einstein's general theory of relativity with the principles of quantum mechanics. The theory of relativity explains large-scale forces and events, including gravity. Quantum mechanics, on the other hand, deals with the behavior of the smallest particles and the forces at play in the very early moments of the universe near the Big Bang. During this period, it is thought that intense quantum gravity could have governed the physical laws. However, scientists have primarily relied on Einstein's theory. While formulating the Big Bang theory and calculating the early evolution of the universe, discrepancies between these two theories may have led to errors. The discoveries of the James Webb Telescope provide evidence of such inconsistencies. Scientists are now faced with a complex puzzle that needs to be solved. The origin of the Big Bang theory dates back to the 1920s when Belgian astronomer and priest Georges Lemaitre proposed that the universe emerged from an incredibly dense and hot point through expansion. Initially, this was called the primordial atom hypothesis. In the late 1920s, American astronomer Edwin Hubble discovered that distant galaxies were moving away from Earth, and that greater distances corresponded to higher recessional velocities. These observations were interpreted as evidence that the universe has been expanding over time. Most of this understanding, which complements these fundamental assumptions and shapes our cosmological worldview, is based on observations and calculations. However, we are now encountering phenomena that do not fit perfectly. Within established patterns and frameworks, the exact timing of the first black hole formations in the universe remains an open question. As ongoing research and investigations continue, different theories about the formation of the first black holes exist, and scientists are actively examining this topic to better understand the early universe. A common theory suggests that the first black holes formed from the remnants of massive stars. These early stars, known as population 3 stars, emerged a few 100 million years after the Big Bang and are thought to have had short lifespans, ending their lives in massive supernova explosions. these explosions could potentially leave black holes in their wake. Another theory posits that black holes might have formed even before the first stars. Under certain conditions, rotating dust disks could directly collapse into black holes, meaning that black holes could have existed before the appearance of the first stars. There are also observations of supermassive black holes. Understanding how these black holes, which have masses millions to billions of times that of our Sun, grew to such enormous sizes in the early universe remains an ongoing challenge for scientists. It is possible that smaller black holes grew by accreting matter and merging with other black holes, but this scenario requires the existence of stars and matter falling into these black holes. The James Webb Space Telescope, with its extraordinary capabilities, has the potential to provide valuable insights into the early periods of the universe. This telescope acts as a kind of time machine, looking deeper into space than previous telescopes and revealing the first galaxies and quasars powered by supermassive black holes. By observing light emitted billions of years ago, it offers a direct glimpse into the secrets of the universe. The discoveries made by the James Webb Space Telescope present astronomers with a great mystery. As it uncovers the secrets of the early universe, it reveals unexpected events that create the need to find answers that will solve the mysteries of the universe. The enigmatic formation of the first black holes emerges as a fascinating cosmic puzzle, challenging our understanding and calling scientists to delve deeper into the mysteries found in the depths of space and time. Subscribe to the Space Telescope channel and hit the bell icon to stay updated with the latest developments.